And this amplifier is going to be a current gain amplifier. So your output is also current, you see input is also current, so output by input is going to be current gain. So this amplifier is a predominantly a amplifier providing a very large amount of current gain. So AI equal to I naught by IS. I naught is going to be the output current by input current, and I naught and IC2 are opposite in direction, so I can write I naught equal to minus IC2 by IS. See, IC2 is the collector of your Q2, and IS is at the base of Q1. So there should be some relation between IC2 and IS, only then I can simplify this expression. For that, what I am doing, I am bringing all the currents into the expression. So I am dividing and multiplying by IB2 so that it will not make any sense. I will divide and multiply by IC1. I'll divide and multiply by IB1. So if you cancel out all the terms, we'll be getting back minus IC2 by IS. So this I am doing just to ensure that I am writing all the currents in terms of the known currents of my transistor amplifier. Okay, and you know IC by IB is going to be beta. So two things I can replace by HFP. IC2 by IB2 will be HFP, and IC1 by IB1 is going to be HFP. And now IB2 by IC1, IB2 by IC1, you have to use current division technique. So it is flowing between RC1 and HIE of this transistor. HIE is going to be the RI2, the input resistance of a second transistor. Use current division technique, you will be getting IB2 equal to IB1 into minus RC1 by RC1 plus RI2. And IB1 and IS, you see, it is also going to be between the source. IS is the total current, and it is divided into R and HIE. So again, apply current division. So IB1 by IS equal to R by R plus HIE. And whenever RI2 is going to be HIE plus 1 plus HFE into RE plus R dash. So I told you, whenever you have this emitter resistance non-zero, all the terms in the expression will be multiplied by 1 plus HFE into RE. So see, that is getting here in the expression for RI2, you can see it is HIE plus 1 plus HFE into RE parallel to R dash. And it is only RE usually, but since here in our equivalent circuit to the output side, we have RE parallel to R dash. So wherever I have RE, I'll be replacing by RE parallel to R dash. And at the input side, you see R is equal to RS parallel to R dash plus RE. So these two are parallel, but among the two, these two resistance are in series. So I cannot simplify any of the terms. So by substituting all the terms in the expression for AI, you can find what is called as the current gain. Now the D sensitivity beta, you know, beta is equal to D capital D is equal to 1 plus beta into AI, and beta value, you know, RE by R dash plus RE. It depends completely on the feedback resistance R dash. And AIF, the current gain with feedback equal to AI by D. AIF equal to AI by D. And this is the current gain